If you attempt to dump an entire enterprise code base into a single LLM prompt, the system will collapse. This happens because of token exhaustion. When a model is forced to load thousands of lines of irrelevant data, it loses the computational space needed to actually reason about the code, inevitably leading to hallucinations. To deploy Claude Code in a production environment, we have to discard the idea of interactive developer chat. Success requires strict context orchestration. We need to architect a modular workflow from first principles. The objective is to control exactly what the model sees precisely when it needs to see it. We will build this by establishing dynamic context routing, implementing isolated subagents, defining clear execution rules, and finally, integrating the system into a headless continuous deployment pipeline. Claude Code's reliability at scale depends entirely on how ruthlessly you enforce its context boundaries. The architecture relies on strict separation between local and shared states. The user-level configuration, found under .claude/claude.md, is strictly personal and doesn't commit to version control. If used for team-wide standards, your engineering team will never see them. To enforce standards globally without creating a monolithic, unmanageable rulebook, we use the @import syntax to selectively pull in modular files. However, if you load every testing, deployment, and API convention into the session at once, you will rapidly burn through the context window before writing a single line of logic. The solution is to use the project-level .rules directory to build path-specific guidelines that only load when actively required. Embedding glob patterns within YAML front matter like .start.testtsx creates a conditional trigger targeting all test files globally. The rule remains dormant, saving tokens until the developer edits a matching file. Only then does the standard inject into the active prompt. Loading the entire repository's rulebook up front floods the model with irrelevant parameters. Dynamic routing filters out the noise. It ensures that Claude reasons exclusively over the architectural standards required for the immediate keystroke. Beyond passive context rules, we must orchestrate active tool invocation. We do this by building custom skills inside the IA-Claude skills directory. A custom skill is a targeted workflow defined by a skill.md file, which gives the model strict instructions on how to execute a specific task. When an agent uses search tools to explore an unfamiliar code base, the verbose output from tools like grep and glob quickly saturate the main context window. We defend against this using the context fork property. This isolated subagent inherits baseline context but executes heavy processing off the main timeline. It completes discovery and returns only a compressed structured summary to the main session. To enforce system safety, we apply the allowed tools parameter to the subagent, stripping its ability to write files and locking it into read-only access. By isolating the subagent, you can run massive codebase analysis while preserving the pristine prompt space required for the actual code generation. With the configuration architecture set, we have to enforce clear rules on how the system executes commands. Direct execution is the default state. It is reserved exclusively for well-understood single-file mutations, like isolated bug fixes with a clear stack trace. If you trigger direct execution for a multi-file architectural change, the model will start writing code without mapping the system, leading directly to blind dependency errors and costly rework. Complex tasks require plan mode. This forces the system to explore and strategize. Plan mode automatically leverages the explore subagent to map out all affected files and library connections before writing a single line of code. Even with a perfectly mapped architecture, relying purely on prose descriptions to instruct the model introduces ambiguity. To eliminate this, provide 2 to 3 concrete input-output examples in your prompt to strictly define the expected data transformations. Next, we utilize the interview pattern. This involves explicitly instructing Claude to interrogate the developer about potential fail states, concurrency issues, and cache invalidation strategies prior to execution. Forcing the system to plan via subagents and interrogate the developer via the interview pattern forces the model to act as a cautious architectural partner rather than an eager code generator. The final structural challenge is migrating Claude Code out of the local IDE and integrating it into an automated, headless, continuous deployment pipeline. By default, the system operates interactively. If it's a pipeline and waits for a developer to manually confirm an action, the deployment hangs indefinitely. We bypass this by executing Claude code with the -p or print flag, locking the system into a non-interactive mode. Headless execution requires strict deterministic data. Conversational text responses cannot be passed reliably by downstream automation. By enforcing the JSON output format flag against a strict JSON schema, we guarantee the model's review findings are perfectly structured and machine passable. Those structured findings can then be piped directly into your version control system to generate automated inline pull request comments. But there is a critical trap here. The specific agent session that originally wrote the code is inherently biased. It will miss its own errors during a self-review. Proper automation demands that you spin up a completely independent review instance. You then inject the prior code findings into its context, preventing duplicate PR noise and ensuring an objective review. A mature workflow requires a multi-tiered architecture. First, it preserves token limits using glob pattern path scoping to load conventions conditionally. Next, fork sub-agents isolate the noise of code-based discovery from the logic of implementation. Finally, strict JSON schemas secure execution within headless pipelines. To build reliable production-grade applications with Claude Code, you must stop writing monolithic prompts and start engineering dynamic context environments.